One of the defining characteristics of human beings is their innate need to interact with the world around them through the sense of touch. This is something that has been observed in every culture and in every stage of development. In fact, as technology advances, many people have begun to think that we are distancing ourselves from the world around us. However, Chuhan Gao, Yilong Li, and Xin Yu Zhang from the University of Wisconsin-Madison have created LiveTag. LiveTag is an attempt to use ordinary objects as a means for interactive controls which operate different devices. It incorporates the ability of controlling objects remotely with the use of one's touch as a sensory medium. It uses thin radio frequency or RF tags as its user interface. Touch commands on the tags are detected by Wi-Fi devices which respond to a given order. Touches upon the metal structure creates a known nonlinear channel distortion which is remotely detected by a Wi-Fi receiver. Specifically, the tag is designed as a strong reflector of 2.4 or 5 GHz from a Wi-Fi transmitter. Live tags are Wi-Fi signal sensitive, contain multiple touchpoints, and bear identifiable characteristics which makes them different from other tags. Two kinds of resonators are being used by this tag, the spiral and the L-shaped resonator. These resonators absorb Wi-Fi signals of a specific frequency, which acts like a bandstop filter to create a distortion on the Wi-Fi channel response. Geometries of these resonators significantly affect the impedances created, which allow boundless modifications to adapt to any desired frequency. However, due to over-the-air usage scenarios, tag detection might prove to be hard due to the amount of ambient reflected signals around. This was why they used customized beamforming algorithms that makes it possible for Wi-Fi devices to detect the distortions caused by the Wi-Fi tag. Some limitations are still present on these tags and have been observed and studied by the researchers. To ensure high detection performance, the tag to receiver distances are limited within zero point 0.5 meters. What makes LiveTag unique? LiveTag eliminates the need for dedicated receivers. It utilizes the Wi-Fi receivers like smartphones, which have other functions and are not solely made to receive signal distortions made by the tag. The tag is also virtually maintenance-free. LiveTag does not make use of any batteries or any bulky electronic components. It is just printed on a substrate, then it is already good to go. Taking a closer look at the substrates, LiveTag makes use of very thin and flexible materials such as ceramic PTEF laminates. Examples of these characteristics can be seen in the flexible music player tag that is located on a sleeve of a shirt. The tag wraps around the sleeve securely and does not get in the way of normal tasks. Another example would be the water level detector located inside a bottle. The tag can be seen to have an increased filter gain with low water levels, while when the bottle is relatively full, the filter gain is zero. A patent similar to that of the live tags would be the chipless passive RFID tag from which this idea was inspired. This was made by a team of inventors who designed a new geometry for their RFID tag. Their chipless RFID tag is made up of many disjoint parallel conducting bands formed on a dielectric support. These conducting bridges interlink neighboring conducting bands and also delimit portions of dielectric bands of distinct lengths. Each portion of the dielectric bands determine a resonant frequency of the tag, which a set of these resonant frequencies identify the ID code for each specific tag. This is evolving so quickly that in fact we can already begin to see the potential that these devices possess. We can expect to see some of these applications to start appearing in the very near future. LiveTag is known to be tag to receiver distance sensitive. This limitation can be used for proximity activated scenarios. Security systems can be fitted with these tags that act as control units for enhanced safety. These tags will only register to locking mechanisms when the tag is within close proximity of the sensor. One tag can be used for multiple locking mechanisms, reducing the bulkiness of bringing around multiple keys or opening devices. Overall, I believe that LiveTag holds enormous potential and that we may soon see such technologies appearing in our everyday life. However, at this present moment, I still see a lot of room for refinement for this technology before it can find widespread success in the global market. To know more about LiveTag, read the official paper written by the authors from the University of Wisconsin-Madison. Here are the references used for this presentation. Thank you.